Okay, to solve this question, we have to understand that EMF is only induced when there is a rate of change of magnetic line of force linking the circuit. So when the magnet comes to a momentary stop, there will not be any EMF induced. So as the magnet is oscillating between P, Q and R, it comes to a momentary stop at P and R, hence no EMF will be induced. So the answer is B. Okay, to visualize these questions, right, we can relate it to a pendulum. So when a pendulum is at the equilibrium position, it will be at position Q, and then when it swings to the top, it will reach a momentary stop at the highest point, and this can be said as R. And when it swings back, it will reach the same height at the opposite side, and this will be P. So at P and R, it actually reaches a momentary stop, and hence there will be no EMF induced. Okay, in this question, right, we have an input voltage of 12 volts, then it will go through a transformer, and then it will go through a pair of long wire, and it will go through another transformer, and we should get 6 volts at the end. Okay, so we are given two transformers. The first transformer, from 50 turns to 1000 turns, it has a turn ratio of 20, so we can either step up or step down the voltage by 20 times. And the second transformer has a turn ratio of 10, so we can either step up or step down the voltage by 10 times as well. Okay, so in order to get 6 volts from 12 volts, what we can do is that we can step up the voltage by 10 times using the second transformer. Then after that, we step down the voltage by 20 times using the first transformer. So it should look something like this. 12 volts, I should connect it to the second transformer, which is coil R, because I want to step up. So R, and then the secondary coil should be S. Then after that, it goes through a pair of long wire. Then now we want to step down, so we should connect coil Q to it first, followed by coil P. Then we should get back our 6 volts. Okay, so the answer here, it should be R, and the coil that are connected to the power line, it will be S and Q, and then the coil that is connected to the lamp, it will be P, and that will give us the answer as D. Okay, as the light intensity increases, the resistance of this light dependent resistor is going to decrease. Okay, and to check the brightness of the two lamps L1 and L2, we need to look at the current that is flowing through the two lamps. Okay, first of all, let the voltage of the cell be V. Okay, the current that is flowing through L1, it will be I is equal to V over resistance of L1. So since the voltage and the resistance of the lamp remain constant, so the current will not change at all, so it will not affect the brightness of light bulb 1. So it's either option C or option D. Then we look at the current that is passing through light bulb 2. It will be the voltage divided by the resistance of the light dependent resistor plus the resistance of light bulb 2. So since the light dependent resistor decreases in its resistance value, the current that is flowing through is going to increase. So light bulb 2 will increase in brightness. Answer D. Okay, we are dealing with a thermistor. So it's been connected in a potential divider circuit. Okay, so let us label the resistance of the thermistor as RT. and this fixed resistor as R. To find the voltage across the thermistor, we will use the formula RT over RT plus R multiplied by the total voltage, which is 6 volt here. So if the resistance of the thermistor decreases when the temperature increases, okay, so what will happen to the potential difference across the thermistor? That means the temperature increases, it will cause the resistor of the thermistor to decrease. So basically it will cause the voltage across the thermistor to decrease, but it will not go to 0. Okay, so the answer should be A. Okay, in this CRO question, it says that the spot takes 1/400 of a second to move from X to Y. So the time taken for two waveform is actually 1/400 of a second. So the period is actually 1/400 divided by 2. So it will be 1/200 of a second, and the frequency will be 1 over the period, which is 1/1/200. This will give us 200 Hertz. Answer E.